Originally, our universe was very hot because of the dense electrons which started interacting with the nuclei. Eventually, as the universe cooled down, it led to the formation of the first atoms. A few 100 million years later, stars and galaxies started appearing. Now the question arises, how did they form this? Well, to know more about this discovery, you have to stay with us. And also, don't forget to like, share and subscribe to our channel. Do you know what a super-Earth planet is? The first potential inhabitant planet is the constellation Cygnus, known as Kepler 1638b. It's about 3,000 light-years away from us. It belongs to the super-Earth class. This planet is twice as wide and 4 times as heavy as our planet Earth. The gravity there feels much stronger, which means that even normal jumps will be much harder than for us on Earth. But if this planet is in the habitat by human beings, we'll be used to living in such conditions. James Webb Telescope is a time machine that has been worth $10 billion in the active development for over 20 years. It's absolutely surprising how NASA found 2 new super-Earths. Let us consider what would happen if the Earth was considerably nearer to sun cake less than 2 hours because of its distance from Earth. So they are so near, gravity has trapped one hemisphere in perpetual blazing sunlight and the other in complete darkness. The ocean begins to boil, the stones start to melt, and clouds begin to rain lava. According to Einstein's theory of relativity, the space and light between objects in the universe expand. As the light from the first stars and galaxies travels in our direction, its waves lengthen, and the light becomes infrared, which is also known as the redshift. So every time when we look up to the sky to see stars and galaxies, we should know that the light coming from them becomes stretched and invisible for us to see. The James Webb Telescope is a compelling telescope that is 100 times more powerful than the Hubble telescope. If we compare the 2 telescopes, we will see that the Webb's mirror is 113 kilograms lighter than the latter. It works in the infrared spectrum because the infrared radiation can penetrate the dust cloud, which allows us to see the stars that are forming within. So how will the James Webb Telescope detect that light? They will be supported by a gigantic mirror, which will increase the number of lights collected. The more the intensity of light will be, the more clear the images will be. The mirror of the telescope is detailed with 18 hexagonal segments, which are 1.3 meters and 4.3 feet or 1.3 meters in diameter. The shape of the telescope allows the mirror to fold on Earth and unfold at the same time. Then the focus of the mirror is measured by shifting segments with accuracy of 1 to 10,000. The light is then collected onto the second mirror, reflecting the ambience sent to the scientific tools. The range of the telescope will help us understand how the rings will form around 4 planets, namely Uranus, Neptune, and Jupiter and Earth. By using the telescope, we can learn the chemical composition of those planets' atmospheres. That will be able to tell us more about the birth of mod, galaxy stars and planets when completely changed. This telescope will certainly help us to uncover some mysteries. Stephen Hawking once said, "I believe alien life is quite common in the universe." The James Webb Space Telescope costs about $10 billion and consumes countless personnel. Expectations are high for this brand new instrument. What is in the near future? Are aliens waiting to contact us? What if the James Webb aliens real-life signals on other planets? That might be possible someday. The James Webb Telescope spent the first day after launch in small rocket engines. It was able to execute the first and most crucial trajectory correction maneuver. It also released and deployed the high-gain antenna to achieve the highest available data communication rates as early as possible. During the first week, the SWIPE telescope executed a second trajectory correction maneuver and began the sequence of significant deployments of the 4 sun shield pallets. The next step was separating the spacecraft bus and telescope by extending the telescopic towers between them. The tower extended about 2 meters and had to be extended so that the rest of the sun shield deployment could proceed. Next, the sun shield membranes were unpinned and the telescoping shield made booms extended, pulling the membranes out with them. The last step in the sun shield deployment was tensioning of the membrane. Meanwhile, other things like radiators were released and deployed. James Webb Telescope finished deploying the telescope structure during the second week by unfolding and latching the secondary mirror tripod and rotating the latching 2 primary middle wings. Various scientific instruments also powered up Kiros to the launch team because due to the flawlessness of the process, the service life of the Space Telescope has been extended. Previously, NASA expected the fuel in the telescope to last about 10 years, but thanks to the efficiency of the launch, the mission can now extend to 20 years of taking breathtaking photos of the most distant places in the universe. However, before the photo starts to flood in the James Webb Telescope, it will still go through months of fine-tuning the individual components using the fine guidance sensor. The telescope will point to a single bright star to demonstrate that the observatory can acquire and lock onto targets, which will then take data manually with a near cam. But because the primary mirror segments have yet to be aligned to work as a single mirror, the James Webb Telescope will obtain up to 18 distorted images of the same single target. NASA will then embark on the long process of aligning all the telescopes from the beginning by identifying which primary, middle segment goes with which image. By moving each segment one at a time, it will end a few months later with all the segments aligned. The cooldown will effectively end. The crypto cooler will start running at its lowest temperature. This step will be followed by calibrating and completing commissioning after interest will take the terms to use the telescope to study the universe. It all started in Australia with the stream signal picked up by the 64-metre Parkes radio telescope. While it was observing proximal Centauri, astronomers were using Parkes to catch radio emissions from powerful flares shooting off the stars. Detection was made by a $100 million project called Breakthrough Listen, led by Andrew Simeon from the University of California, worldly funded by tech billionaire Yuri Milner under the umbrella of Miller's Breakthrough Initiatives. The goal of this multi-year endeavour, which began in 2015 with a star-studded announcement attended by Stephen Hawking and other space science luminaries, is to buy observing time on radio telescopes around the world to search the style for evidence of technological civilization. Their pursuit is more commonly known as the search for extraterrestrial intelligence. Using Parkes, astronomers observed the star for 26 hours as part of their stellar flare study, as in routine within the Breakthrough Listen to project. They also flapped the resulting data for a better look to see any candidates set signals. The task fell to a young intern in someone's SETI program at Berkeley, Shane Smith, who was an undergraduate at Hillsdale College. Smith began sifting through the data until a curious narrow bandwidth emission made him curious. From there, things happened fast. According to Sophia Sheikh, it is the most exciting signal we have found in the Breakthrough Listen to the project because we haven't had a signal jump this many of our filters before. According to Hertog, Hawking was not satisfied with the state of understanding of the multiverse. Hawking's final paper suggests a framework for understanding the universe that would render the multiverse finite, countable, and subject to a meaningful engagement via the tools. Interestingly, Hawking helped develop the theory that led to the idea of infinite universities, which is the eternal inflation theory, but he admitted that he had never been a fan. In one of the interviews, he quoted, "The usual theory of eternal inflation predicts that our universe is like an infinite fractal with a mosaic of different pocket universes separated by an inflating ocean. The local laws of physics and chemistry can differ from one pocket universe to another, which together would form a multi-purpose. But I've never been a fan of the multiverse if the scale of different universe is in the multiverse is larger to infinite, the theory can't be tested." Hawking and Hertog light on string theory, a branch of physics that tries to reconcile quantum physics with gravity, and Einstein's theory of relativity. He came up with a new idea of eternal inflation that relies on a boundary at the beginning of time. The idea suggests that at some point in time when we trace the evolution of our universe backward in time, we arrive at the threshold of eternal inflation where our family and notion of time ceases have from the boundary. The new theory predicts a finite structure of the universe emerging from the Big Bang. If this theory has proved true, it would recommend that other universes like our one could have emerged at a point and there could be that matches the inflation of the universe, but this new model is still far from proven, and physicists need more data and a better understanding of the string theory before that is possible. The paper also implies that it might be possible to test this theory. However, the existing instruments that were not sensitive enough to find the evidence of this theory, but that does not stop scientists from trying to seek evidence of other universes using tools measurable in space-time, which is also known as the primordial gravitational waves. And these scientists have more physical hard evidence for the existence of the multiverse if a living universe happened to be closed long ago. It may have collided with the universe without creating an unnoticeable imprint that could be in the form of distortion in the cosmic microwave background, which is the light left over from when the universe was 1,000,000 times smaller than it is today. Please let us know what you think about this James Webb Telescope, which is finally proving Hawking's multiverse theory. Let us know your opinions in the comments section below.